All right, welcome back from fall break. Hope you guys had a good week off. Got some time to refresh, and you're ready to go. Now, as we talked about right before, you'll notice there is still chapter 4. It's kind of a piggyback on what we just did. It's only going to be 1 week here. We're going to have a lesson Monday, Tuesday, and Wednesday. Then Thursday will be your quiz review on paper. It's in the back of the packet. And then Friday, you will take your quiz. If you lost your packet or weren't there on Thursday before, you can print it off. It is included in the folder at the top, but if you need an emailed copy, let me know and I can get that to you. So today we're going to start by talking about long division. Okay, so synthetic division and long division generally accomplish the same thing. However, there are a few times where long division is more beneficial, and one of those times is when we find like a remainder. It just helps keep things a little more organized. You can use synthetic division, but sometimes there are limitations. So I'm not going to talk too much about those limitations right now. We're just going to refresh on what is long division. So here we have 890 divided by 7. If you remember, we write the 890, put the division over it, and put the 7 out front. And the first thing we have to do is think to ourselves, what's on top? Now, when I say what's on top, what I mean is what number times this 7 will go into 8. So I'm going to choose 1. If I do 1, then step 2, I'm going to multiply. So the reason I chose 1 is because 7 goes into 8 one time. 1 times 7 is 7. And then step 3, we will subtract. And keep in mind, if it was negative, that means you're going to change your sign. Now, in our case, the 7 was positive, so we're just going to subtract it. 8 minus 7 gives us 1. We drop this 9 down, 19. Okay, now, so step 4 here is drop down, and then we go back up to the top, and we do it all again. So we think, how many times can 7 go into 19? And hopefully you know it can go in twice because 2 times 7 is 14. Now, that was multiplying. Now we got to subtract it, so we do minus. We'll get 5. We drop down that 0 again, 50. So how many times can 7 go into 50? And it would be 7 times. 7 times 7 is 49. So we subtract, and we get 1. 7 does not go into 1, so that 1 is what we know as our remainder. Okay. Sometimes we're going to have a remainder. Sometimes we won't. Just depends on does it go in evenly. So now, when we're dividing with polynomials, we follow that same approach, okay? Except it might look a little more complicated. So I'll start by writing out what I'm going to divide into. And then I'm going to put 2x plus 5 at the front. Okay, so for this, only worry about this first term, the 2x. What would I have to multiply 2x by to get 2x squared? So I'm going to think 2x times this blank box would equal 2x squared. What times 2x would give me 2x squared? And hopefully you guys know x. So now I multiply it. X times 2x gives me 2x squared. That's good. X times 5 gives me plus 5x. Okay, now we have to subtract or change the sign. So this becomes negative. This also becomes negative. We subtract down the 2x squared and the negative 2x squared cancel. We get negative 14x here. Don't forget, drop that negative 35 down. And now we're thinking 2x times what? So I'm going to put a blank box again. Would give me negative 14x. And we need it to be negative, so we know it's going to be negative because we have a positive 2x. It's going to be negative 7. So negative 7 times 2x gives us negative 14x. Negative 7 times 5 is negative 35. Remember, we subtract, so we take the opposite of both of these, which is good. That cancels out to 0, and we have no remainder, and right here, that is our answer. Oops. All right, so now let's go ahead and we'll do one more on the front like this. So once again, we're gonna set it up. We know the 3x plus 5 goes out front. In here we have a 6x squared plus 7x minus 15. And we want to know how many times does 3x, what does it have to be multiplied to get 6x squared? So that's going to be 2x. If we multiply, we'll get 6x squared plus 10x. So now subtract, we'll get negative 3x, drop it, minus 15. So this time we need to get to a negative, so it's just going to be minus 1. It already was 3x, which is what we wanted, but we needed it to be negative, so all we have to do is multiply by negative 1. Negative 1 times 3x is negative 3x minus 5. We switch both those signs, and we'll get negative 10, and that is our remainder because there's no way for 3x to go into negative 10. Okay, so maybe you want to make this note, just a reminder. Sometimes you get a remainder, sometimes you don't. And sometimes you don't. All right, now some of you might not be the most confident at this, so I'm not requiring it, but if you ever want to check it, all we have to do is, oh dear. All right, sorry about that. I accidentally closed out of my document, but in order to check it, all you have to do, so let me write this quick to check your answer. We'll start by multiplying whatever we divided by and whatever our answer was. So in our case, we're going to FOIL those. So 3x plus 5 and 2x minus 1. And then in our case, we also know there's a remainder of negative 10, so we need to add that on at the end. So we multiply here, we get 6x squared minus 3x plus 10x minus 5. Don't forget minus 10 at the end. And when we combine our like terms, we get 6x squared plus 7x minus 15, which if you look over here, 6x squared minus 7x minus 15. So we have succeeded, so I'm going to put a check mark. All right, so now this next one, as we flip to the back here, it's very similar, except now it's just an x out front. It's the same concept. It's just now it'll actually be a little more simple because when we multiply it in, there's only going to be one term. So we're thinking, what times x would give me 3x squared? We know that's 3x. 3x times x is 3x squared. Do the opposite, so subtract it. We'd get 0, but this drops down. Now we have an 8x. So times positive 8 gives us 8x. Got to subtract it. We get 0, but this comes down. We have negative 5, and that is our remainder. And remember, if you want to check it, you can. I'm not requiring you check them all, but sometimes maybe if you're a little confused, did I do it right? Just double check it, make sure. So example 5 here, using long division to divide once again. However, I want to make a note. Sometimes we have to put in zeros for any missing exponents. Now, when I say missing exponents, what I mean is it needs to go down in order. Okay, remember, just like in synthetic division, every place value is important. So right here we have a 3, a 2, unfortunately right here we're missing a 0x. Okay, there's no x term, so that's important for us. So when I set it up, I'm going to put 2x to the third plus 5x squared plus 0x minus 2. And the reason that just helps us keep our spacing, helps us keep track of what place value each one is in. So what would we multiply x squared by to get 2x to the third? And hopefully we know there'll have to be a 2, and we'll need another x. So 2x to the third. Now we haven't had this yet. This is going to give us negative 2x. I don't want to put this under the x squared. Instead, I want to line up of my like terms. So 2x times negative 1 gives us negative 2x. I'm going to put that there. Now, once again, we change our sign. So minus, that becomes plus. Add down, those will cancel at the beginning. The 5x squared just comes down. We get plus 2x, and go ahead and drop that negative 2. Okay, so once again now, we need to multiply to get a x squared to turn into 5x squared. So we need plus 5. 5 times x squared gives us 5x squared. And then 5 times negative 1 will give us a negative 5. We got to change our sign, so minus, that becomes plus. Add straight down, we're going to get 2x plus 3. X squared cannot go into a 2x, so this is what we know is our remainder. Okay, we're going to do one more together. This one, similar to the last one, so if you want, you can pause it. However, the difference is this time we have x to the third, x to the second, x, and a 3. We don't have to add anything in. All the terms are there. Each place is represented. So we multiply. We'll put a 3 there. 3 times x squared, 3x squared. 3 times negative 3 gives us when I wrote it down, instead of an x squared here, this should have been an x to the third, which means this actually needs to be 3x. So 3x times x squared gives us 3x to the third, which means 3x times negative 3 will give us negative 9x. Once again, change the sign of both. We add it straight down. We get negative 2x squared plus 8x, drop the 3, plus 3. Okay, at this point, we know we're going to have to multiply by a negative 2. Negative 2x squared plus 6. But then we're doing the opposite, so plus minus, we add straight down. We're going to get 8x minus 3. And that will be our remainder because, once again, x squared cannot go in. Now, let me show you real quick if we wanted to check this one. So to check it, once again, we're going to FOIL. This time I'm going to wait. I'm just going to deal with these two terms, and then I'm going to add this on at the end. And I'll show you why. So we know it'd be like x squared minus 3. And then we got 3x minus 2 as our answer. Once again, this is optional, but some of you might find it helpful. So we'll get 3x to the third. Outside, then minus 2x squared. Inside is minus 9x. Last would be plus 6. Now, this remainder, the 8x minus 3, once again, just keep it in line with its terms. So I like to say, let's add that on. So we'll add the 8x here, the minus 3. Since we're adding, the signs will stay the same. We'll add straight down. We'll get 3x to the third minus 2x squared minus 1x, or just minus x if you prefer, and then plus 3, which if we look back here, 3x to the third minus 2x squared minus 1x plus 3, exactly what we have. So we did it. All right, so take a look at today's activity. Hopefully it shouldn't take you that long. If you need any help, please reach out, and I'll talk to you later.